Great. Good morning. My name is Derek Huckaby. I'm a technical marketing engineer in the enterprise switching group within Cisco. And I'm here today to talk to you about network as a sensor and enforcer, and really talk about how we've extended the functionality in the last couple of releases to all of our Catalyst platforms. So obviously security challenges continue to grow, right? We have a growing surface attack. What does that mean? That means that we have lots of different devices coming into the network that have never been there before. We have the IoT devices coming in, vending machines, closed circuit television, anything that you could think of, we can now put it on the network, right? In addition to that, attacks are getting much more dynamic. They're getting much more sophisticated in how they go about doing things. It's no longer just simply a bunch of sins coming in from all over the internet. They're getting inside the internet or inside your company and then proliferating through it to find weak spots so then they can get data and make their attack a little bit more useful for their purposes. In addition to that, how to protect your network has gotten a lot more complicated, unfortunately. At the RSA conference recently, there were over 500 vendors working in this space of security alone. Most customers, large customers, are looking at buying 50 different products from 50 different vendors to protect their network in different niche areas all over the place. So now you have to have a very specialized set of staff and resources to manage and deal with all those different entities, right? So let's look at how breaches happen today. What we're seeing now is through social media, the attackers are going through and learning about individuals that work at a company. Once they've done that, they'll go out and purposely focus on that one individual to try to get them to click on a link to try to sign into a site. And they're very sophisticated. It's very hard now to tell the difference between a real site and a phishing site unless you truly look at the source code behind the invites. So once they get in, the victim simply clicks on it. And at this point, download the malware, and now the attack begins. And notice that we're actually inside all of our perimeters, right? So now we're beyond the firewalls. We're inside. We're authenticated. We're in Active Directory. We're a happy user that's now attacking the network with no knowledge. So what do? Now they become lateral attacks. So now they're just trying to find any other user on the network that has administrative capabilities to get to some asset. And they're not very picky, right? They're just trying to find anyone, and they'll just continue to spread until they find someone. Once they've found someone, then they escalate the attack. Now they're actually trying to go into the servers and other devices inside the network. Once inside there, then it's relatively simple for them to capture all that data, package it up, and export it back out. And this is the type of attacks that we're seeing today. All inside the firewall. As far as the firewall is concerned, all the actions are completely accessible and allowed, right? So how do we protect against this? So what we're looking at Cisco is providing network as a sensor and enforcer. We'll let every single switch provide visibility into the traffic that's coming into it. At the same time, be the enforcement point to stop traffic from going out. So not only does it show the visibility into a central device that will allow you to analyze that traffic data, but then if you need to take action on it, we can push policy down to all the switches to enable that to take action, whether it's to just simply quarantine or whether it's actually to drop traffic. So one of the things that's surprising now is 25% of all the attacks are from malicious insiders. That's a huge increase from over time. Almost all of the issues that we're seeing are from these lateral attacks now. They're not people beating down the front door, coming through the firewall, headstrong. Sure, there are still some of those, but the most of them are, once you're inside, doing something outside. Your point of sale all of a sudden became an exit point for all of your database credit card numbers. How'd that ever happen? Well, it's allowed to talk to the databases that store those numbers to do transactions. So it's perfectly normal to allow it to receive some information. Probably shouldn't receive a terabyte of information. And still the passwords, even though we have lots of password security enforcement now on devices and inside systems and networks, and definitely inside Cisco we have lots of it, still most of the breaches come from simple password breaking. So humans are still responsible for weakening the overall security system. So what we really want to do is how can we solve this holistically? And what we see as an end-to-end solution is to provide network as a sensor and the enforcer. And this will allow you to take analysis of what your network does normally, so you understand how it works day one. You can harden the devices that you need to harden up front. While you have an attack, to be able to recognize that there is an attack, try to take action while it's happening to limit the scope of the attack. And then finally, to have the data so you can go back and do an analysis to figure out what was caused by the attack, what was damaged, what was taken, and then to remediate the problem as well. So what does a secure networking architecture look like? So it consists of Netflow and TrustSec. And so of all the entry points into the perimeter, we want to make sure that we have Netflow and TrustSec capable products. And what this will allow us to do is, as traffic comes in, detect any type of threat or vulnerability. And so as it comes in, we have two products, a Stealthwatch that we'll talk about in depth today, and a Firesight for the next gen IPS. These are allowing us to look at data as it comes in and detect anomalies in traffic versus what is normally considered normal traffic, right? So we can see anomalous behavior based on trends that we've made over time. Once we've determined there's a problem there, we can talk to our ICE, which is doing our identity services engine, and this does all the policy control. And so now from Stealthwatch or from Firesight, we can do adaptive network control to quarantine those devices or to completely drop traffic that those devices are sending. So it gives us a time to take real action at the moment that we have a detection. Inside the network, TrustSec runs throughout, so you're able to have different policies. You can actually qualify something as infected traffic or quarantined traffic, and then track it through different tiers of systems, completely silently to the customers, so they don't really realize the flow of data has changed. So we can redirect that flow of traffic to do additional analysis to see where it came from, to hold it up a little bit, to inspect it more, to capture more information, maybe do full packet scans of just that traffic. But all that's possible once we have it tagged in the beginning. So with Stealthwatch, which is a critical part of this whole system, because this gives us the visibility to monitor and maintain this system. So the switch infrastructure and any of the devices inside the network are providing Netflow data to Stealthwatch. Okay, and it does that into this flow collector. And this flow collector can sit inside your network, or there can be multiple flow collectors inside your organization that receive this Netflow data. And this Netflow data is a flow record for every single transaction that's made through the switch. So every single connection, there's a summary of it through Netflow that gets sent to the flow collector. Now this flow collector can grab information from direct sources, or we can have a flow sensor. So if you have switches or devices that don't produce flow initially or natively, we can use a flow sensor to redirect the traffic into them, and then they will produce those flows for us. We'll get that information into the flow collector. So every device could possibly provide flow. There's lots of different devices inside a network that use flow. So we need a way to replicate those flows when they're not using the same collectors. And so we have a UDP director that will allow us to send flow data to multiple distribution points. So if you have one using for logging, you have another one doing for policy control, then you have Stealthwatch that you need to do for analysis, then we can have 3 different flows from one source. All of this Netflow data that's in the collector is actually talked to the Stealthwatch management console. And this is really the GUI interface. This is the brains of what we're really showcasing. This is how we visualize all the information that we're going to parse in the flow collector. We'll talk a little bit more about that later. In addition to this, we've already talked a little bit about how ICE is interconnected into this information for doing things like quarantining. We also have a threat feed license that allows us to get patterns captured in. So if there's some types of sequences or some types of footprints, we can see that in the network, and we can grab that information and then apply policy based on that information. So what does Netflow really give us? Minimally, version 5 gives us the source and destination IP and port, the type of service, the protocol, and the interface. And so that's the information that we get with basic Netflow. Now with Netflow version 9, we're able to get additional flow information. And this is really useful. We can get things like, here highlighted is the source group tag or security group tag. We're able to get Also application information. So if you happen to have NBAR inside your switch and data running through that, that NBAR information can be put into your Netflow. So not only are you getting this TCP or UDP flow, but you know that this is web traffic. We know for a fact, no matter what port it's on, this is FTP traffic. But that's determined by NetBar putting in the application information. And so from this is great. We have tons of information now, right? But unfortunately, if you go to each switch, it's still just a lot of distributed information. You need a way to pull all this together, and that's where the flow collector is so important. So the flow collector is getting all this data, and it's able to start putting together information in conversations. And so now we know that these two entities were talking, this client, this server. And it may not be a true client or true server, but this person initiated conversation, this person received the conversation. So now we can say, okay, these two endpoints are really talking, and here's the communication they had over the lifetime of that connection. So we're getting more visibility in. But the big key for the flow collector is to be able to dedupe packets. So you typically don't have a small network of 3 switches, right? You typically have a network of hundreds of switches. Well, now if we're getting flow from hundreds of switches, imagine looking at packet traces coming through multiple switches all at the same time. It's going to be a nightmare. So what the flow collector's real benefit is the ability to dedupe these to get it down to just the flows that you really need to see. And the nice thing about this, if you have flows in your network that only can produce, or devices in your network that can produce Netflow version 5 or version 9, or version 9 plus additional fields, the flow collector will be able to summarize all those so you get the result of all that information in totality. Does that make sense?
Just a quick question, do you also support other flow formats from third-party or open source, like IPFix or...
IPFix, yes. The Stealthwatch will support SFlow as well. So what does all this go? So basically what we end up doing is we have lots of different entities that need to have visibility. And what we're able to do with Stealthwatch is we're able to provide that visibility through session data. All of this is for every single packet, right? So every packet that's on the wire gets calculated into the Netflow data and gets sent up to the flow collector. So you have 100% accountability of what's going on inside the network. Inside Stealthwatch Management Console, we're able to go through and trigger on security events and behavioral analytics. So we can start seeing what's going on and make decisions based upon how those flows are acting.
I see here that the traffic is 20 megabytes or something. Is it for both directions aggregated, or can you also see up and down or inside and outside? Because we're tracking a lot of breaches by looking who is sending a lot of data to the internet, while users shouldn't normally do that. Usually they receive a lot, they don't send a lot. Right. So we're looking at who's sending a lot and receives just a little.
So the nice thing is inside the screens, this is the high level view. You can double click on this and it will give you both sides of the conversation and pretty graphs to show which way traffic is going ingress or egress.
And you're probably also putting alerts on things like that.
Yes.
Yeah. Okay.
And then these are the use cases that customers are really buying for. They want to solve these use cases up at the top. And so by having Stealthwatch, we're able to do all of this. So we can give you all the visibility that you need to solve the business use cases that you're trying to solve inside your networks.
How much is the load that you put on the devices for this? Because I've seen a lot of people who are concerned with this. If I talk to network administrators and I tell them I need Netflow to track lateral movement, very often they will tell me, no, we're not going to do this because it will kill the switch performance or whatever. And sometimes they offer to give me a sampling rate of every 1,000th packet. It's like,
In some switches, the reason they have to do sampling is to keep it in hardware. They can only sample, especially high data rates. It's very difficult right now with where we are in the world for the ASICs to produce one-to-one sampling on 100 gig interfaces, for example. However, using the power of the Catalyst 3K and 2K, the processor inside of it, we're able to actually do everything in hardware. And so all the sampling is done in hardware. It's all full Netflow, so it's one-to-one sampling. And the overall load that we've seen so far in the testing we've done at least is when we have the switch completely full, we haven't seen more than about 6% increase in CPU. So we're thinking that's reasonable for most environments. We haven't seen any problems to this date that would tell us not to turn on Netflow, for typical environments. And we can scale to high enough numbers for access and access for all of the flows coming into the 2K and 3K. And that's really important to make sure that whether you have a single switch or a stack of switches, you're still able to support all those connections coming in.
Regarding to the performance on the Stealthwatch side, how many flows can you receive with a single box, or how's the scalability?
So in the flow collector, it comes in different versions for different size scale capabilities. It's well over 400,000. I don't know the exact number, but they've just come out with a new flow collector 5100, and I'm sure it's up at the World of Solutions if you'd like to see all the scale capabilities of it. So here, this is a conversational flow. As you can tell, we have the time information about when it started and when it stopped. We also know where the subject was, right? So who's actually doing the communication. We know that the traffic overall was HTTP, and we know who they were talking to. So we're talking to somebody in this example in Canada. And down here at the bottom, you can tell that we have TrustSec ID, so we know the ID number, but more importantly, we know the ID tag, so we know that this was an employee. And that's really what we want to do going forward, is simplify this so we don't have to correlate numbers to tags. It's just tag information that we know. So let me cut over to the demo real quick and just show you a little bit of this. I know we don't have much time. We have quite a number of booths that are up in the World of Solutions and throughout the event. Quite a number of labs that are going on in the walk-in self-paced labs as well as instructor-led labs. So be sure to stop by there to get more information and really hands-on with Stealthwatch. Okay, so this is the Stealthwatch management console. And here we can tell there's multiple different alarms that can be generated. And so these are defined by default. And so you have your command and control types of alarms, the data hoarding, exfiltration, which is what we discussed earlier. All those are defined here. They're all customizable, so you can go inside and customize each of these. We can set up individual policy violations. Down here shows historically what type of issues are going on in the network. Here we can come down and we can double click on these. And you can see who is actually creating the trouble and the error. And so these are the people that had the problem. And so you can click on them to see more information about what's going on. And so here we see most of their communications to the data center, but there's some information going outside the campus and to the United States. We have the ability to quarantine and unquarantine here. We can come down to this, and here's the graphs that we were talking about earlier. So you can see all the information that was sent or received. And then you can see it over different trend lines. And so we have the ability to historically go back months to track all of this information. And here we know the user was Andy. And so this information comes from Active Directory, which is pulled through. We're also connected into ICE, our Identity Services Engine. And so what makes this nice, if we want to go over here, and since Andy's a current user on this address, we see Andy doing something that's not normal. What we can simply do is go through and manually say quarantine. Now what have we really done? Well, we've gotten Andy completely quarantined off the network. So what does that really mean? Over in the Identity Services Engine, if we go and look at the live log here, we can see now that what happened is Andy was part of a corporate PC. There we go. Andy was part of the corporate PC. So he was given all the permissions corporate PC would be given. But now that he's done something interesting, we've quarantined him so we can do additional studies to see what's going on. And so we've actually given him a different tag inside the network. And so now the network can behave or operate on that tag accordingly. So whether it's to block his traffic egressing the switches, whether it's to send him some other device. We can do all that completely transparent to Andy. Andy's had no idea that anything has happened to his connection whatsoever. And the nice thing about this is all this is, again, inside the firewall perimeter. So this is your actual access devices. This can be done between two devices inside the same access switch, right? Inside the same VLAN, we can provide this type of capability. Any questions?
So only to clarify, this integration is always going to the Cisco ICE, yeah? Do you have also a way to enforce something on firepower or on an ASA?
So firepower will learn the policy from ICE using PX Grid, and then it will be able to enforce policy inside of firepower.
So if I get it right, you always need a Cisco ICE to enforce that, yeah?
Yes.
Okay.
Yes.
Okay, I have a question. You showed that you had this user Andy from
Yes.
Active Directory. This is a real problem for Germany because we're not allowed to basically have usernames and stuff like this being shown just like that to anybody sitting in front of the console, because you get into trouble with the workers' council most of the time. Is there a way to have a pseudonym or something in there to show something like user01, and then if we get the permission to deobfuscate him, to show the real username? Because this will be a real big problem for deployment in Germany, because nobody will allow this kind of thing to run, because it's like worker surveillance.
Understood. I believe there is a way to do the user ID, but we need to verify with the team to make sure.
Okay. And then the other thing, you said that you're baselining the network being in a good state to find things that are happening in a bad way. How can you be sure that there's nothing bad happening already?
Good and bad are a little relative. Where we would baseline the network and see what's going on in the network, and then you could apply the base default rules that we have to see how those work, right? But going through there, you could also see and track, is this allowed, right? Is the traffic I'm seeing right? And as you've gone through the couple of weeks of looking at all the traffic, through that you'll figure out what's working and what isn't working inside your network. And then after that, you have that trend. You'll know all of a sudden if user 347 all of a sudden sent all their data outside, then that's a problem. That's a different behavior than what that user was doing 2 days before.
Okay, so is it sort of recording what is happening and what is normal, and then you say at some point, now this is my normal observation base, and
yes, so in all of the policy violations, all the different rules that you can set up, you can set different thresholds, and there's a very advanced way of looking at all this data to give you different concern indexes. And so the concern index would be, you'd want that to typically stay low, but if they changed in groups, for example, they would have a different behavior that day when they switched groups. But that might be okay. If all of a sudden they outputted all their database for your secure docs, that would be a problem, and you would want that to trigger something, a violation somewhere. So you have unbelievably granular control of all of that inside Stealthwatch for setting up these policies and rules.
so that sounds like you have a set of rules that you fine-tune to your network, and at one point you say, okay, this tuning is now complete,
Right.
and then you go basically on active enforcement mode.
Exactly.
Yeah. Okay.